Okay, so we are going to be solving systems of linear equations with two variables. We've already done the warm-up, so we're going to start with our first way to solve it. The first way to solve the systems of the equation is to solve it by graphing. So to do that, we're going to, write each equation in slope-intercept form. That's why we did the warm-up. 2, graph each equation. And then 3, find the intersection. The intersection is actually going to be your solution. So when I'm saying find the solution of the system, I want to know where the lines intersect. That's the whole idea. Just as a reminder, how do we find an x-intercept? Where do I plug in 0? Great. Plug in 0 for y. Solve for x. Okay. So for my x-intercept, remember I should have some x value, comma 0. Then how would I find the y-intercept? Just call it out. Plug in 0 for x. You got it. Plug in 0 for x and solve for y. So my y-intercept is going to be some 0, comma y. This is the review. All right, let's go ahead and go on to this first question here. All right, so first step, it said to get it in y equals mx plus b form, right? So I need to rewrite this equation. So to do that, I would subtract x on both sides. And then I would divide both sides by 3. Divide this by 3, divide this by 3, divide this by 3. Right, I get y equals negative 1/3 x plus 1. Any questions about how I got that? Okay, so that's what I mean by new equation 1. So I'm acting like this is my first equation. My new equation 1, when I rewrite it, is negative 1/3 x plus 1. Okay. What is the y-intercept? Well, now it's easy to tell, right? Now let's in y equals mx plus b form. I know that my b value is 1, and my slope, negative 1/3. Okay. How do I find the x-intercept? Plug in 0 for y. So I'm going to plug in 0 for y. Solve for x. I subtract 1 on both sides. I get negative 1 equals negative 1/3 x. Then how do I get x by itself? Great. Divide by negative 1/3 or multiply by the reciprocal, which would be negative 3. Great. So I get that 3 is x. It actually might have been easier, rather than plugging it into the new equation, it might have been easier to plug it in here. Yeah, if I plugged in 0 for y here, you would have just gotten x equals 3. That might have actually been easier. So either version of equation 1, you can plug it into, whether it's the rewrite or the original. I don't care. Whatever's easier. Okay, so we end up with 3, 0 for the x-intercept. Let's go ahead and graph it. We have y-intercept 0, 1, and then I'm going to go down 1 over 3. Down 1, right 3, down 1, right 3, etc. Okay, and we're going to draw our line. Use a straight edge on your homework. Like use a student ID or a planner or a ruler or something to make your line straight. Okay, let's do the same thing with equation 2. So now I'm looking at this equation 2. I want to get in y equals mx plus b form. Right? So I'm going to add x to both sides. So when I add x to both sides, I should get y equals x minus 3. Is that okay? y-intercepts, my p-value, so I'll have 0, -3. And the slope, I'm going to pretend that there's an imaginary 1 here. Right? If nothing's written in, you're assuming it's 1. And for the x-intercept, plug in 0 for y, so I get 0 equals x minus 3. So if I add 3 to both, hey, I have the same x-intercept. Okay, so let's graph that. We'll have 0, -3. I'll do this graph in green. 0, -3, 1, 2, 3. And the slope of 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Right? What is the solution to that system? Where do they cross? Like 3, 0. So your answer is 3, 0. So when you're writing your final answer, go ahead and put it in a big box. That is your solution to the system, is their point of intersection. Okay? Any questions about that? It's not always going to be the x-intercept. So you want to make sure you're drawing a really straight edge, because you might have to keep using the slope until you get to a nice point of intersection. Okay, it's not always going to be an intercept for the intercept. Okay, the other method is solving with substitution. Okay, so here are the steps for that. Rewrite one of the equations in the form y equals or x equals. Substitute the expression from step 1 into the other equation. Solve the equation for the first variable. Once I get one variable, like I get x equals something, then I need to remember to plug it back in to get what the other variable is. Okay, so substitute the value of the first variable back into the original equation to solve for the second variable. Okay, and then once you have your answer, you want to just check your work. That's the idea. Okay, so I need to get one of these equations in the form y equals or x equals. Okay, got to get one of the variables. Okay.
For the second one, we could do x equals y plus 3. If you would
add the y
on both sides, and then divide by -1 on both sides, that would be y.
Sure. So you want to solve it for x? That's fine. Okay, so you said subtract y on both sides.
Yeah.
And then divide everything by -1. Divide both sides by -1. So we'll get x equals, that would be y plus 3. Okay? Alright, so I saw that's my first step, right? Get it in the form equals x equals or y equals. So once we have this in the form x equals, I'm going to take this guy and I'm going to plug it in for x in the first equation. Right? I rewrote the second equation and I'm plugging it into the first. So we'll call this equation A and this equation B. Does everyone understand this is my rewrite of equation B? Because I'm rewriting equation B, I have to plug it into equation A. Okay, plug it into the other equation. So I'd end up with, I'm plugging it in, so what do I need around it? Y plus 3, and replacing x with y plus 3. Plus 3y equals 3. Any questions about that? Okay. Really, I don't need the parentheses here. I can drop the parentheses. Don't need them. We'll combine like terms. We get 4y plus 3 equals 3. If I subtract 3 on both sides, I get that 4y is 0. So what's y? 0. Right? If I take 0 divided by 4, I'm going to get that y is 0. 0 divided by anything is 0. Okay. I get y. What do I still need to know? X. So where am I plugging 0 in? You can plug it into x, you can plug it into b, or you can plug it into the rewrite of equation b. Where is it going to be easiest to plug in y equals 0? I would think that the rewrite of b would be easiest, right? Because then it's just 0 plus 3. Okay? You can pick any one of those. Just pick whatever is easiest. Okay? I'm going to pick the rewrite of b. X equals y plus 3. X equals y plus 3. So x equals 3. Okay? I don't want you to leave your answer like that. Remember, when we're solving a system of equations, what are you really finding? You're finding a point of intersection, right? So don't just leave this as 2 boxes. Okay, when you're solving a system, I want it written as an ordered pair of points. So an ordered pair is always x comma y. So my final answer would be 3 comma 0. Which, is that the same system that we just graphed?
Yeah.
Is it? Hey, it's the same system we just graphed. So we just solved it algebraically. So, okay, so that's solving it algebraically, and then the last example we solved it graphically. Cool. All right, what do you think about B? Do I need to rewrite anything first? No. Michaela, what would you do?
I would substitute on the 3x minus 14 the other
Great, so she said I'm going to substitute this 3x minus 14. It's a y value, right? So in equation A, I'm just going to replace y with that whole thing. Instead of writing y in this equation A, I'm just going to replace it with 3x minus 14. Okay, so we'll have x plus 2 instead of y. I'm inputting 3x minus 14, and that equals 14. Again, anytime you plug it in, put parentheses around it. Okay. Any questions about that? Morgan, what would you do from here? Perfect. Let's go ahead and distribute that 2 through the parentheses. X plus 6x minus, what is that, 28. Thank you. Okay. Combine like terms. You get 7x minus 28 equals 14. I lied. Add 28 on both sides. 8, 9, 10, 11, 12. Carry the 1, 2, 3, 4. That's 42. Is that right? Okay, divide by 7, and what do I get? 6. And I'm done, right? No, what do I have to do? Plug x back in. Doesn't matter which equation I plug it into. No, just simplify your life. Make it easy. Okay. So you can do the first one or the second one. I'm going to do the second one. I think the second one looks easier. If I plug in x here, I would have 3 times 6 minus 14. And that would give you what y is. Y equals 3 times 6 minus 14. What is that? What's 18 minus 14? 4. Am I going to leave my answer like that? No. And I'm going to write this as an ordered pair, 6 comma 4. Any questions about solving using substitution? So there's that. And then we have one more method. And the last method is called elimination. Okay. For elimination, we need to first make sure that the equations are in standard form. Ax plus by equals c. You want to get x and y on the same side of the equal sign. Okay. Once it's in standard form, we're going to multiply one or both equations by a number that will create an opposite coefficient for one of the variables. That way, when I add the two equations together, it eliminates the variable. So like if I have 3x and negative 3x, and I add them together, we don't have any more x terms, right? They cancel each other out. That's why it's called elimination. We're going to solve for whatever variable is left. And then the same thing, plug the solutions back in, and then you always want to check your work. Okay? All right. So, example A again. I already have an opposite coefficient for x. Does everyone see that? I have a 1 and a negative 1. If that happens, when I add these together right now, one of the variables is already going to drop out. I don't have to multiply by anything. X plus negative x, that goes away. 3y plus y, that's 4y. 3 plus a negative 3, 0. Y equals 0, right, when I divide both sides by 4. Okay. Then what? Plug it back into one of your original equations. I'm just going to plug it into, we'll call this equation A. I'll plug it into equation A. X plus 3 times 0 equals 3. So x equals 3. Shouldn't really come as any of a surprise because we already did this problem with graphing, and then we did this problem with substitution, and now you just saw with elimination. So, personal preference, which do you think is easiest? Elimination works best for that one. It was the least amount of work. Alright, now B. Let's talk about B. If I were to just add these two equations together right now, I would get 3x plus 3y equals 18. Does that help me solve for one of my variables? No. So I have to ask myself, okay, I want one of these variables to go away. What would I have to multiply equation A or equation B by so that when I add them together, one of the variables goes away? Dan?
Multiply equation A by negative 2.
Okay, so I'm guessing you're looking at x. So this says positive 2x. It would be really nice if this guy said minus 2x, right? So how are you going to make that happen? Just take equation A, and we're going to multiply the whole equation A by negative 2. Every single term. So x gets multiplied by negative 2. 2y gets multiplied by negative 2. 14 even gets multiplied by negative 2. See how every single term changed in equation A? Equation B I'm not going to touch. I'm just going to leave it alone. 2x plus y equals 4. Not going to touch it. Just going to leave it alone. Now look what happens. Negative 2x plus 2x. Those go away, right? We expected that to happen. We intentionally made that happen. Negative 4y plus y, negative 3y, and that equals, what would that be, negative 24? So what is negative 24 divided by negative 3? 8. And I'm done, right? No! What do I need to do? Plug it back in. Does it matter which equation, A or B? Doesn't matter. Okay, pick whatever one you like better. I'm going to go ahead and do equation A, but you could do equation B if you wanted to. Alright, so we're plugging it back into equation A. We have x plus 2y, and in this case y is 8, equals 14. So we get x plus 16 equals 14. If I subtract 16 on both sides, we end up with negative 2. Okay. How do I want you guys to write your final answer? A coordinate. What's going to come first, the negative 2 or the 8? Negative 2. Negative 2, comma 8. And you'll notice that I say for all methods to check your work. We are going to be working with equations next week where some of the solutions are going to be what's called extraneous solutions. We'll get solutions that we actually have to cancel out of our solution set. You always want to check and make sure your solution is a solution. What I mean by that is here, if I get negative 2/8, I want you guys to plug it back in and see if it balances not one, but both equations. You have to check for both. Because if it doesn't satisfy both equations, then it's not a solution. If it only satisfies one of the two equations, it's not a solution. So I have to plug in negative 2, 8 up here. I'm plugging it in for x, negative 2, plus 8 was y, equals 14. Does the point negative 2, 8 balance that equation? Negative 2 plus 16. Is that 14? Yes. You also have to check the second equation. 2 times negative 2 plus 8 equals 4. And I'm plugging in negative 2 for x and 8 for y. Does that work? Negative 4 plus 8 is 4? Yeah. Okay, so see how it's a solution? Because it balances both equations. I want you to do that for every problem. If you're handing in a quiz to me, you should know if you got the correct solution, right? Because you should be checking your work and making sure that it balances both equations every time. Okay? So, even on this one, go ahead and do this one with me really quick. Let's practice checking our work here. Right now, if I add these two equations together, is a variable going to drop out? 8 plus negative 3, that's 5. Y plus y would be 2y. See how the variables then drop out? I can't solve a two-variable equation. That doesn't work. So what do I have to multiply one or both of them by in order to get one of those variables to drop out? Negative 1. Blake, why do you say negative 1?
Because if you multiply negative 1, then 1 to y should be negative.
Great. I'm looking at these y's. I'm like, ooh, we have 1y. It'd be great if the other one was negative 1y. So let's go ahead. Let's keep a the same. Let's keep that 8x plus y equals negative 16. And let's take all of equation b and multiply every term in equation b by negative 1. So negative 3x is now positive 3x. Positive y is now negative y. Negative 5 is now positive 5. Adding those together, we get 8, 9, 10, 11, 11x. Ah, the y's drop out. I like that. Negative 16 plus 5. Negative 11, right? Is that right? Negative 11? Divide both sides by 11 and we get negative 1. Right? Plug it back in to one of the equations. Let's say I plug it into the top equation. I don't know. 8 times negative 1 plus y equals negative 16. Let's see, what would y equal? If I add 8 on both sides, negative 8. Okay, so let's say our solution is negative 1, negative 8. How do I make sure that that's a solution? Plug it back in. Do I just plug it into one equation? No, just satisfying one equation is not enough. It needs to work for both equations, right? So negative 1, negative 8 is our solution here. Oops, can't close that off. I'm going to do it over here on the board to verify. Plugging in negative 1 for x. Plugging in negative 8 for y. Does that equal negative 16? Is negative 8 plus negative 8 negative 16? Yeah. Okay, try it in the second equation. I'm plugging in negative 1 for x, and I'm plugging in negative 8 for y. Positive 3 minus 8 is negative 5. Yeah, that works. Okay, see what I mean? I need you guys to check your work, check both equations, make sure it's satisfied. Because when we come in on Monday, some of the equations that we have, we'll have to eliminate some of the solutions. Some of the solutions maybe. Questions, concerns, comments?